Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 39 of Physics 5054. In the previous lecture, we were discussing pressure in liquids and we did one work example. Today we are going to study the second work example, which is more important than the first one. In this we will derive a conclusion. So first let us learn and understand the work example 7.3, which is on page number 102. Ladies and gentlemen, it is saying that a rectangular block of cross-sectional area A of 25 centimeter square. So let us write the data. In the first part, it is not needed, but we are writing it area, and that is 25 centimeter square. That is 25 centimeter square. This is the area of this rectangular block. Is submerged in water of density. So we are writing density, and that is a very famous 1000 kilogram per meter cube is the value. It is given, but by any means, if it is not given, then you have to memorize it. This is very famous value, 1000 kilogram per meter cube, is shown in the figure. In part A1, they are saying find the pressure P1. We have to find the pressure P1 where due to the water only acting on the top surface. We have to find the pressure on the top surface. So we will write the formula is pressure 1 is equal to rho g h1, and h1 is given as 0.05 meter. Instead of G, we are writing 1000 rho, and G is 10 N. H1 is 0.05 and pressure is in Pascal. So we will write it as, so 5.0 into 10 raised to the power 2. 5.0 into 10 raised to the power 2 Pascal will be the pressure at the top surface of this rectangular block. Similarly, in the second part, they are asking us that find the pressure P2 at the bottom surface. So, ladies and gentlemen, here we will find P2, rho is constant, G is constant, and H is a variable. So, we are labeling it as H2. Ladies and gentlemen, again we are putting 1000 into 10 into H. 2, and that is 0.07. So that will be equal to 7.0 into 10 raised to the power 2 Pascal. Ladies and gentlemen, the first conclusion we are deriving from these two parts is that pressure is greater at the bottom surface than the pressure at the top surface. The pressure at the top surface is 5 into 10 raised to the power 2 Pascal, while pressure at the bottom surface is 7.0 into 10 raised to the power 2 Pascal, which is confirming our explanation that pressure increases as the depth increases. So here the depth is more at the bottom surface than the pressure at the top surface. Now in second part we are going to find the number 1, the force exerted by the water on the top surface. So we have to find the force exerted on the top surface, and we are labeling it as F1. As we know that pressure is equal to F divided by A, which is force per unit area. This implies that F1 here we are labeling it as F1. So F1 is equal to P into A. Pressure at the bottom is given, at the top is given as 5.0 into 10 raised to the power 2, and area is given as 25, and that will be Newton because it is force. So to calculate it we are going to find it as uh, 2.5 into 10 raised to the power minus 3. 2.5, it is 2.5 into 10 raised to the power minus 3 Newton, which after the calculation it is given as 1.25 Newton. 1.25 Newton. Ladies and gentlemen, in the second part they wanted us to find the force exerted by the liquid at the bottom surface. So we have to find F2 in this case. Again, as we know that pressure is equal to force per unit area, to differentiate between two forces, we are labeling the first one as F1 and the second force, which is at the bottom, is F2. Now from this equation we can derive that F2 is equal to pressure into A. So pressure again is given as 7 into 7.0 into, this is 7.0 into 10 raised to the power 2, and again 2.5 into 10 raised to the power minus 3. It is centimeter, so we are converting it into meter, and that is 25 when it becomes 2.5. So it means it will be 10 raised to the power minus 3, because taking square of centimeter, cent means 10 raised to the power minus 2, and when we double it, it will become 10 raised to the power minus 4. But because this is 25, when one decimal portion is going to the left, so it will become 2.5 and 10 raised to the power minus 3. Okay, ladies and gentlemen, this is calculated to be 1.75 Newton. Now, ladies and gentlemen, if you give a closer look to these two values, force exerted on the top is less and force exerted at the bottom by the liquid is greater. Uh, the difference between the two forces, let me write it, the difference between the two forces is called upthrust. It is called upthrust. The difference between the force at the top surface and between the bottom surface. In this case, if we subtract 1.25 from 1.75, so it will be 0.50 upthrust. So we defined another term, and that is upthrust. Uh, Ladies and gentlemen, when we are swimming in a swimming pool, we are feeling ourselves very lighter. When you are swimming, the effect is due to the upthrust acting on you. And why we are feeling lighter when we are swimming and dipping ourselves in the swimming pool. And I heard that this effect can be feel inside the space as well. If we want to see the effect of body in the space, we cannot go to the space. Dip yourself in the swimming pool, then you will feel lighter. The same case is in the space. When the scientists are going to the space, they are feeling weightless, very lighter. So if we are swimming in the river or in the swimming pool, the same effect can be felt here. Ladies and gentlemen, now we are turning our focus to a very important topic, transmission of pressure in liquids. And we will also study hydraulic system. First of all, let us understand this figure. There are two pistons. One is F of X, the subscript is X, and the second piston, which is a bit larger than the first piston, and we are labeling it F with the subscript of Y. Why X and Y? Because we are finding the forces at 2 points at the same level. This is the point X and this is the point Y. Because water maintains its level, so pressure will be the same at the same level. So we are taking this point and this point at the same level. And you must also remember that pressure at this particular point will be lesser than the pressure in this particular point, which is Y. Why it is so? Because the piston one is smaller one, it will exert a smaller pressure, and there is another point which is y, and here the area is larger one, so it means that here the force, the upthrust will be greater. We are labeling that there are two forces, which is Fy and here it is F1. Why we are deriving all these things? Because if we apply a smaller force on this area on this piston, it will be transmitted through this liquid to the piston number 2. And if we are putting a heavy object above the piston number 2, so it means because here, here and all the places there will be pressure, and because the area is larger one of piston number 2, so there will be a larger force. We will apply a smaller force, and as a result we will get a larger force, and this larger force will uplift a heavy object. This concept is used in hydraulic systems. There is a hydraulic brake system, there is a hydraulic press, and there are many other applications of this transmission of pressure in the liquid. So if we apply a force here through this liquid, that pressure will be transmitted to this place. And if you are ever been to a car washing system, you must have observed that by a small force on one piston, they are uplifting a very heavy car. So it means that small force can be applied on smaller area, and large force we will get as a result due to larger area. Let us say that at this point there is a pressure applied at x is equal to pressure and then fx and then a of x. This is a general equation. Pressure is equal to F divided by A, force per unit area. But because we are specifying it for point X, so we are labeling each point as X. P is labeled at X, and similarly F and X. Ladies and gentlemen, we know that Py is equal to Px. We know that Py is equal to Px. Ladies and gentlemen, this is because pressure at the same depth will be equal. Pressure here and pressure here will be the same. Pressure here and pressure here, because it is at the same level, will be the same. So we took these 2 points X and Y at the same level. So we are observing that it is same. Pressure at point Y will be equal to pressure at X. Now we are putting F of Y divided by A of y, and here f of x will be equal to a of x. We are putting these values because we wrote px is equal to fx divided by ax. So instead of px, we wrote this value. Similarly, you can write that py is equal to fy divided by ay, and this is equation number 2. We are putting the corresponding values inside these two equations, and as a result we will get this. Now, because we are finding f of y, so f of x divided by a of x and a of y. If we want to find force applied by the liquid at point y, so this will be the equation. If we are applying a force x here, then pressure will be transmitted, and at y we will get force at point y, we will get this point. Since the area of ay is larger than ax, it would mean that the force fy would also be larger than fx, because this area is larger than this area, so the force at the larger area will be greater than the force at the smaller area, which is point x. So you have to keep this in mind, and let us do the work example 3, work example 4, using this concept of transmission of pressure in liquids. So wait for a minute, then we will come back. Okay, ladies and gentlemen, let us read the question which is on page number 103. The diagram above shows a simplified form of a hydraulic press, which is given there. A force of 15 Newton. This is 15 Newton force at point X is exerted on the small piston of area 0.025 meter square. And then they are saying that the large piston has an area of 0.50 meter square. In the first part, they are saying that calculate the pressure exerted on the liquid by the small piston. So ladies and gentlemen, as we know that at this point P of x will be Fx into Ax. All the values are available. So Fx is 15 and Ax is 0.025. When we calculate it, then it comes out to be 600 Pascal. 600 Pascal. Now, ladies and gentlemen, in the second part, they are saying the pressure exerted on the large piston. So, many students are confusing themselves that because this is a large uh, piston, so pressure will be large. No, it is not like this. Pressure will be the same at the same level. We are talking about the force exerted on piston 2 will be larger. Pressure will be the same. So, pressure will be equal to 600 pascal as we found it here. So pressure at the same depth will be the same. So whatever pressure at point X will also be at point Y. Now the third part is force on the larger piston. So force on the larger piston, and that is F is equal to Y, is pressure at Y will be equal to force at Y and area of Y piston. So because we are finding F of Y, so we will write P of Y into A of, so P of Y is equal to 600. We found in this case both are the same, and AY is given as 0.50. 0.50. It is here 0.50. So when we calculate it, so Fy comes out to be 300 Newton, which is very larger than the force at point X. It is 15 Newton force at X point, and you will get 300 Newton at the, if you are applying 15 Newton force here, it will give you at piston number 2 as a 300 Newton force. So it means that force exerted by the liquid on the piston 2 will be greater than the force exerted by any machine or any external body will be smaller. That is 15 and this is 300 Newton. Ladies and gentlemen, the next topic is hydraulic system. We will talk about this hydraulic system in the next lecture. Also, we will tomorrow, inshallah, discuss measuring atmospheric pressure. So, don't miss the tomorrow's lecture. For today, that's it. Have a nice time. Allah Hafiz.